Hey guys, welcome back to my channel. This is Varun. Now that we have understood how do we use various Python libraries for analysis of data and visualize them, this is the right time that we now take a leap ahead and learn some aspects which are essential before starting machine learning. And one of such aspect is learning inferential statistics. So in the coming session, we will shift our focus more towards learning some basics on statistics and its various terms and methodologies. This is needed for understanding the distributions in the dataset and interpreting them on the basis of some statistical paradigms. Now, before going ahead with the concepts, we will first understand the meaning of this term, which is inferential statistics. Okay, so if we break this term, it comprises of two words and then it becomes self-explanatory. So it comprises of inferential and statistics. So statistics is the practice of science of collecting and analyzing numerical data in large quantities. Okay, so I'll just write here collecting and analyzing. Okay, so here we will collect some samples of data that will represent a small proportion of large population and then infer. Okay, so infer means to deduce and conclude. Okay, so this is the dictionary meaning. So what we are deducing is we will deduce the probability for the rest of the data based on the results we have for this sample which we collected. So inferential statistics as whole means inferring proportion in a whole from a representative sample that we collected. Okay, so it's all based on probabilities. Now for an example, let's say that we have a task at hand to find the defected products from a large data set. Let's say that we have 100 million products, okay, and out of that we have to find the defected product. So instead of taking all the products and their data, what we will do is we will take small chunks of data to take the defected product rate out of, let's say, 10,000 samples. Okay, so we'll start with 10,000 sample products and calculate their defect product rate and then conclude for the rest. Okay, so this is what we will do. So this is called inferring or deducing the defected products in the overall items based on the already deduced ones from the samples. So it is a part of survey where we collect the data samples and then we will look at the distribution of the data, and based on that we will deduce the probability for the large samples given that sample data. So the purpose this technique solves here is that collecting huge samples will take a lot of time and resources, but this technique will give you more or less approximate results to what is obtained with large data set. So now that we have understood the concept of inferential statistics, let's move on to probability. So probability is an extent to which something is likely to happen. You might have come across probability word in past also. So it is all based on chance. Okay, we'll try and understand this with the help of an example. So let's say that we do an experiment on flipping of a coin. So we have a coin over here. This side will be head and the other side is a tail. And let's say that we flip a coin only once and we are expecting heads to come. So our expectation is heads. Okay. So we need to find the probability of having heads, assuming that the coin lands flat on the ground. Okay, so either head will come or tail will come on this side. Okay, so either head or tail. So this is a random experiment, guys, with no sure answer. So we will calculate the probability to define the chance of having either heads or tail in this case. So how is this done? So for this we need to know two things. First thing is how many number of equal likely possibilities are there, and second thing is among these equal likely possibilities how many are the event of my interest. So how is probability calculated here? So the probability is calculated on the basis of the number of events. Okay, so in denominator comes the equally likely possibilities and in the numerator comes number of possibilities that meet my condition. So here guys, what will be the answer? So the equally likely possibilities are either head or tail. So head and tail are two different events. So 2 will come here, and number of possibilities that meet my condition is only one among those. So from head and tail, we are only expecting head to come. So here we will have 1. So the probability will be 0.50. So this is in percentage. So we always calculate probabilities in percentage. And the another way to look at this is, if I do this experiment of flipping a coin like too many times, so let's say 1 million times, what percentage of those will give me heads? And you will see, if you actually perform this experiment, you will land close to this number, which is 50%. Now, as we have seen by the probability equation, that it is total number of favorable outcomes by total number of outcomes. So by that we mean that this PE which comes as an output will always be between 0 and 1. So by between 0 and 1, I mean that it will be always greater than equal to 0 and less than equal to 1. So now that we have seen the probability and its range, we can scale this. Okay, so I can create a scale of likeliness and unlikeliness. So it will always start from 0 and it will end with 1. So 0 being the impossible condition. So this is the least likeliness. So if we want to take an example for this, let's say that we have a coin and we are finding the probability of it standing on the floor instead of falling flat on the surface. So generally this does not happen. So we can say that it is an impossible condition unless some conditions or some air conditions are specified. Okay. And in the middle of the scale, there is even chance. So even chance means either of the possible conditions can happen. So in this case, if we talk about the fair coin, which is having heads and tail on the other side, so in that case, either tails can occur or head can occur in a single toss. Okay, so it has an even chance. That is 50% chance. Okay, and then in this scale, there is this which is unlikely, and this is likeliness. By unlikely, I mean less than 50% and greater than 0. And by likely, I mean greater than 50% and less than 1. And probability equals to 1 will be a certain condition or 100% chance. So this will be 0% and this will be 50%. So how it can be 100%? We can take an example for this, taking the analogy for the coin again. So let's say that we have a biased coin this time with heads on both the sides. So in this case, if you toss the coin also, you will get heads at every toss. So let's calculate the probability here. So the total number of outcomes becomes 1 because there is only head and no tail here. So 1, and total number of favorable outcome is also 1 because we need head. So we are calculating the probability of having a head. So this is then 1. So 1 means 100%, which is the most certain, or you can say every time this will happen on toss of a coin. So now that we have understood how probabilities are calculated, we will understand some of the terminologies associated with those, because we will be using these terms quite frequently in the upcoming sessions as well. So experiment means repeatable procedures. So the example for this can be throwing of a dice, or tossing of a coin, or even selection of a card from a deck. Okay, so any of these can be regarded as experiment. Now outcome are possible result out of the experiment. Now example of this can be getting a 6 after throwing a dice. Now sample space is all of the possible outcomes of the experiment. So example of this can be choosing a card from a deck. So our sample space are all the 52 cards that are present in the deck, and from that we'll choose one. So our sample space becomes 52. Now sample point is just one of the possible outcomes. So example of this is, if we talk about cards, then getting a 5 of clubs from a deck of card, or getting a king of heart, or even throwing of a dice. So in this, the sample space becomes 6 because there are 6 different numbers in the dice. In this, the sample becomes 1 because there is only one king of heart in a deck of card. For this also, the sample is 1. But for this, there are 6 different sample points in the sample space. Now, event is one or more possible outcomes. The example for this is getting a tail when tossing a coin. Okay, so this will be an example of one outcome. And then there can be possibly for multiple outcomes. That is, example can be seen as choosing a king from deck of cards. Now, as you know, in a deck of cards there are 4 kings. Okay, so event can be 4 here. So this is an example of more than one outcome. Now, to understand sample and event better, we'll take an example. So let's say that Alex wants to see how many times a double comes up when throwing a dice. So what we have is a pair of dice and we are throwing these at the same time. So we can get a pair of numbers when throwing these dice. So what is the sample space? You can recall that this is all the possible outcomes that we can get. So we have to make the pair of numbers that we'll get while throwing the dice. So there can be 1, 1, that is getting 1 on one dice and 1 on the other dice as well. Then there can be 1, 2, then likewise 1, 6. So like this there can be 6 sequences and we'll have the sequences like this. Okay, so this will make a 6 into 6, that is 36 combinations. Okay, or we can call them as sample points. Now what is event? Event is getting a double when both dice have the same number. So what will be the sequence that we can get? 1, 1, 2, 2 and likewise 6, 6. Okay, so there can be 6 possible events. And what is the probability for this? This is 1 over 6 because we have 6 combination of this event. So 6 and we have a sample points 36. Okay, so 1 by 6. So guys, before moving on to the next topic, let's first look at some of the examples in probability and try to solve these problems. So the question says a die is thrown once. What is the probability that the score is a factor of 6? So what are the factors of 6? That means which all numbers starting from 1 to 6 have 6 in their table. Okay, so we can find that 1, 2, 3 and 6 has 6 in their table. Okay, so these are 4 numbers and the die has a total of 6 numbers. So out of that 4 numbers have 6 in their table. Okay, so this becomes 4 by 6. So this becomes 2 by 3. Now we will look at the second problem which says a fair coin is tossed 3 times. What is the probability of obtaining 1 head and 2 tails? Okay, so we have to make several combination here guys. So we can make it like this: head, 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 and then tail, 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 and then head along with head, then tail, tail, and then head again, and then tail again, and then head, tail, head, tail, head, tail, head, and tail. Okay, so this will cover all the possible 8 combinations. So we have to find out of these 8 combinations what all combinations have 1 head and 2 tails. So we can check from here that this combination has 1 head and 2 tails, and even with this and this. Okay, so this becomes 1, 2 and 3. So 3 out of 8 combinations is the probability. Now here comes the third question. It says committee of 3 is chosen from 5 counselors: Adam, Burke, Cobb, Dilby and Evans. What is the probability or possibility of Burke to be chosen? Okay, so for this I am just aliasing them via their initials. So this is A, B, C, D and E. And what we'll do is, among these 5 counselors we will choose 3 and make the combinations. Okay, so one possibility can be A, B, C, then A, B, D. Okay, so among these we can see that this and this combination has Burke in it. Okay, So among 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 6 have Burke in it. Okay. So this becomes 3 by 5 as the probability. Now we have another question which says a die has 8 equal faces. So we are considering a special dice which is an octahedron, and we have to calculate the probability of getting a prime number. So guys, you can recall from your basic mathematical concepts that prime number is a number which is completely divisible by either 1 or itself and not by any other number. Okay, so we have to find the numbers which are either divisible by 1 or itself and not by any other number, and which are between the number 1 and 8, because we are considering octahedron dice here. So 1 is neither composite nor prime, so we'll exclude this. 2 is a prime number, then 3 is a prime number, then 4 is not a prime number, then 5 is a prime number, and then 6 is again not a prime number, then 7 is a prime number, and then 8 is again not a prime number. So we have 1, 2, 3 and 4 number out of 8. So we have a probability of 1 by 2. Now there is this another question which says that we have a bag of balls which contains 3 red, 2 blue and 5 green balls, and we have to calculate the probability that a person drawing a ball from that bag does not pick a red ball. Okay. So first we need to find out the total number of balls in the bag. So it is 10. Okay. So 5 plus 2 is 7 plus 3 is 10. Okay. Now the chances of picking not a red ball is we have to count the remaining ball. Okay, which is green and blue. So 5 were green and 2 were blue. So out of 10 balls, 7 balls, that is 5 plus 2 is equals to 7, are not red balls. So we'll get a probability of 7 by 10. So guys, this brings us to the end of today's session. It was a shorter session just to give you a glance at what probability is. In the upcoming session, we will be looking at the rules by which probability operates, along with the problems like we have solved just now, elaborating and clearing all your doubts. I would like to thank you all for appreciating my efforts as I just reached 500 subscriber milestone. It feels great, so please continue liking my content and subscribing me more so that I can work harder on bringing quality content to you guys. Also, please let me know if you want some topics to be included in the part we are currently following for data science, and actively ask questions in the comment section. I will see you soon in the next session. Until then, thank you and take care.